Today we are going to go for another component for the mold design component for diploma tool and die making. Today you are going to see the component here, the component, and this is the top view of the component, and it is the front view of the component, and it is the side view of the component. In this component introduction, you are going to for an instance, you are going to see the dimensions of the component. I am showing here the component. This one is the top view of the component. You are observing here the top view of the component. This component has the like mainly in three sections. This one section, and the second this section, and third one this section. And then you are observing this the boss extrusion from the component. Actually this extrusion will be here, and the component has been sectioned. The component has been sectioned here. The component has been sectioned through this cross section. Through the cross section, you are observing the front view of the component. This total length of the component is 80 mm. From this to this one is 80 mm, and this height, the first height is 20 mm, and the second height is 30 mm, and the total height of the component is 40 mm. You are observing, and in the front view you are going to observe a hole. This one hole is there. This hole is diameter 12 mm, and opposite on the top of the hole another boss is there. That diameter is 20 mm. This diameter is 20 mm, and the inside diameter of the component is 12 mm. You are observing, and mainly the wall thickness is 4 mm. Wall thickness of the component is 4 mm. Wall thickness component is 4 mm. Wherever there is wall thickness is there, you have to go for the wall thickness 4 mm. And for this section, and in the side view, I am going to give this section in the side view. This section, you are going to observe this section. In this section, you are going to observe the boss. This one is the boss. This one is the boss, and this length of the boss is 10 mm, and this diameter of the boss is 12 mm. From the bottom of this one is from bottom of this component, the dimension is from here to here is 9 mm, and the diameter is 12 mm. And here the another one drilling is there, one hole is there. That hole diameter is 4 mm. You are going to observe this one, and then the boss the same. This one is the same, and you are seeing in the side view. This is the introduction to the component. The component is made up of the material ABS, acrylonitrile butadiene styrene, and here the shrinkage is given for this plastic material is 0.6%, and for the general tolerance where for the component is given is the 0.1 mm, and the draft permissible is 1 degree, and hole wherever the component thickness is there and dimension is not shown, you have to take the wall thickness is 4 mm. This is the introduction to the component. Are you observing? The total height is 40, 30, 20, and this one is 80, and here this one is 10, and the total this length is 40. This length is 40, and then this length is 9 mm. We are going to observe this one. Here for this component, the component has the boss in the side. That means the component, the tool for this component requires the side core, which is going to draw drawing sheet, 1:1 drawing sheet. And this for this component here, it is the requirement is 2 cavity plastic injection molding, and with the edge grade and pin ejection and finger cam actuation. This is the requirement of the tool and the requirement for the component. Again, you are going to observe for this component. For this component, I had already in my last classes, I will give the principle. I will give the principle how the core and cavity is placed, including the side core and the finger cap with the elements of the mold, plastic injection mold. You are observing here. This is the back plate of the tool, and this one is the core housing plate, and this one is the cavity housing plate. Above this one cavity housing plate is the top plate. You are going to observe this is the top plate, and this one is the parting line, and you are going to this one is the parting line, and here is the insert. Main core insert is there here. Core insert. This one is the core insert, and this one is the cavity insert. I will write it down for your things. This is core insert, and this one is the cavity insert. This one is cavity insert, and you are observing this one is the core back plate, and this plate is the same. This plate is the core housing plate. This plate is the core housing plate, and then similarly I have given that hatchings for your kind observation. This one is the core insert, cavity insert, and core housing plate, core back plate, cavity housing plate. This one is the cavity housing plate, and this one is the top plate. This is the introduction for the principle. Here this is the core insert and cavity insert. Inside the core insert, again you will see the core insert. This one is the local core insert. Is here. Local core insert. This insert is there. Again, in this insert, you have to place another one insert. This is the insert. This is the main insert. This is the insert which will gives the internal profile for the component. This insert will give the internal profile of the component. Here for the ease of showing the side core, I had used the side view of the component. This view I had used for here for ease of the showing the component in the design. Here you are observing here the tool which had the component in the side view. You are observing the component. This component is in the side view, and then this is same side view I had used here for ease to show the side core movement and where the side core is used actually in this component. Here you are seeing the insert, and at the same time you are also seeing the cavity insert. This is the cavity insert also. This is the cavity insert. This is the cavity insert. This is the cavity insert which gives the external profile of the component. Except you are observing here the cavity insert which gives the external profile of the component, except the boss of diameter 12 and the pin of diameter 4, which is actually used for this hole. this hole will be through the pin which is actually used in the side core. By this pin you will get this hole, and at the same time the side core has a depression of diameter 12. You are observing this one, the diameter 12, the depression in the side core. You are observing this one is the depression which is machined on the face of the side core. So when you have the depression in the side core, you will get the boss or extrusion on the component. Similarly in the boss it is have the diameter 4 pin, diameter 4 pin core pin, diameter 4 core pin, which is used for getting this hole through the side core. You are observing here, when I will place a molten metal through the feed system, and it carries through the sprue and runner, which is the modified trapezoidal runner, and through the gate, that is the edge gate, you will fill the component. You have to fill the component. I am showing this one. This is the component. You are going to seeing your the component is filling, component is filling, component is filling, component is filling. Here you are going to observe this is the component is filled. The component is filled by the movement of the molten metal, by the movement of the molten metal through the feed system, screw bush, puller, runner, gate, and then the cavity. Now you are clearly observing that the side core has the depression or machined a blind hole of diameter 12 to the length of 10 mm, and at the same time through in this boss again the component requires the diameter 4 mm hole. For this diameter 4 mm hole in side core, a core pin, this one is you are observing, this is the core pin, this is the core pin, this is the core pin which is placed in the side core. After completion or after curing time, here you are observing the parting line. Through the parting line means when the parting line is open, when the parting line is open or the mold open with the actuation of the finger cam, the side core moves backward. The side core will moves backward, and through the pin ejection, the component is ejected from the cavity. This is the actual principle which is going to use for this component in this mold design. For your reference, I will provide the plate thickness. For your reference is there. Here, for your reference, I am giving the plate thickness. This one is the core back plate. The thickness is 22 mm, and core housing plate, that thickness is 66 mm, and the core insert, main core insert thickness is 46, and here the cavity housing, that cavity housing insert, that thickness is 56, and the cavity housing plate, that thickness is 76, and the top, that thickness is 22. At the same time, if you are observing here, this one is the this is the wear plate which is used in the backside of the side core, at the backside of the side core. Here the wear plate thickness is 5 to 10 mm. You can have this one, and the thickness of this side core is 66 mm. And mainly you have to observe and you have to draw in your side core. This one is the wedge. This one is the wedge. You are going to place in the. You have to place in the top plate, and this is the main wedge. This is the wedge. This is wedge. This is the main insert of the tool or main element of the tool, which is going to lock the side core to coming out of the tool during the force of the molten metal enters into the cavity. This is the principle, and I had given the introduction about the principle and how the material will be filled in the gap of the core and cavity. With the help of the side core, we will get the side wash and the hole in the component. This one is the principle here. You are observing the components, given components, the plastic injection mold for the given component. Here you are observing the top view of the tool. This one is the top view of the plastic injection mold for the 2 cavity for the given component, and this one is the front view of the tool, what you are observing. And at the same time, I had drawn the core inserts, cavity insert, and main core insert, and core housing plate with side core, and the section of the side core you are observing here. Going through the top view of the tool, here similar to the other plastic injection molds tools, here you are observing the from 4 corners you are observing main, guide pillar, guide bush, and similarly the 4 ejector screws or fasteners, what you may call, and then here this one is 1, 2, and 3 and 4. Here are the feed buttons used between the bottom plate and then ejector assembly. Along with you are observing the main core insert. This is you are observing here. This is the main core insert. This is the main core insert. This one I am giving the dimensions here. 300 length. This one is the 300 length, and width is 130 mm, and the thickness of the insert is 46 mm. This one is the main insert. This one is the main insert. This one is the main insert, in which the tool has 2 cavities. Means the component at one stroke you will get the 2 components. Here for this reason 2 cavities are machined, 1 and 2. Here this one is 1 and 2, and here you are observing this one is the 1 cavity and then one is the 2 cavity. This one is the 1 cavity and this one is the 2 cavity. The same thing, this is the isometric view. I am showing here the core insert, main core insert made up of the HDS. This one is this one too. This one I am giving the dimensions also, and in this machining or the pocket open, in which core insert, these core inserts are placed here. Here this one is 1 and this one is 2, because cavity is 2 and the quantity is also 2. Quantity, this core insert is 2 quantities. One is placed here and the similar one is placed here, and with the assembly I am showing here the top view. With this assembly I am showing the top view, and this top view is this one, and similarly this top view is this one I am showing here. This one is the cavity 1 and cavity 2, and in between cylindrical hole or wire cut. Here I placed the sprue puller bush with the sprue puller pin. Accordingly, same here I have to generate the runner with gate. The sprue puller similar here, and you have to make the runner. That one is the modified trapezoidal runner, and at the end of the runner you have to make the gate. That one is the edge gate. Here this one and this one. This you know it, and in the top view, similarly we have to place the ejector guide pillar and guide bushes. Symmetrically we have to place the two ejector guide pillars and guide bushes, which will help the ejector assembly to move up and down easily during the ejection. And similarly, you are going to see here in the top view, this one is the side core. What you are observing, this one is the side core, which is the main part by which the side profile of the component we can get. The side profile is the boss in which the hole is there. You have to refer the component drawing. This one is the top view of the side core. This one is the top view of the side core. Similarly, when you see this is the top view of the side core, you have to imagine that one the isometric view of the side core. You are seeing here isometric of the side core. When you see this one is the side core, and you have to assume is one like this, this one, and you have to assume like this here. This is the isometric view of the side core. I had given the dimensions for your reference only. While you have to drawing in the design sheet, following 1:1 drawing, you have to observe the where the projections will come, or for your calculation wise, you have to calculate likewise with the projections. And again in the top view, you are observing this one. You are observing this is the guide. There are two guides. This one is the one guide, and second one is the second guide for the side core to come forward and go backward during the finger cam actuations. You are observing this one, and this one is the guide, one guide and the second guide. In this tool, you are observing there is only one side core is there. There is only one side core, because the component necessitates only for the one side boss, or the projection or the extrusion with the hole. The another side, the component doesn't have any profile. So for this reason, side core required is one. The side core with two cavities here. I given the pitch also for your kind reference. Again in the top view, already you know that the four corners are placed with the main guide pillars and guide bush, and the top view also have the four pushback pins for the ejector assembly. Similarly, this tool, when you observe in the top view, the cooling circuit is rectangular cooling circuit. What I had used here, from this one, from here here and this one. Here from this side the cooling circuit moves, and this one from this the cooling circuit will come out. Means the water has to move from this end and covers this one, and it comes to going to outside. This is the rectangular circuit, or you have to make it as a U circuit also. That's no problem. Again in this tool, there is a this is the side core. You are observing the top of the tool. You come to know that all the elements are there. And main important, another one thing is that after the curing time and the mold opens, here the component is ejected by the pin ejection method. Here I had provided the ejector pins. Observing here 1, 2, 3, 4, 5, 6. 6 ejector pins are placed here like this. 1, 2, 3, 4, 5, 6. 6 ejector pins are there. Diameter you have to choose for the dia 4 ejector pins. Dia 4 ejector pins. And similarly this is what the component has been placed in the side view format. Means where the side core is there, in this view only I had drawn like this in this tool the sprue puller or the sprue bush, the sprue puller pin, it cannot be sectioned as like this. I had already shown this one already shown this one. For this section, similarly for this section, it shows only. At the same time, here the main guide pillar, guide bush also I didn't show, and I shown only the component. I shown only here the component and core insert and the main core insert. This main core insert, and this is the insert I didn't show there, and this one is the also insert. This core insert is this one. This is the core insert. This is the core insert. Again, this is the cavity, main cavity insert. I didn't show there. This is the cavity insert where the external profile of the component is done. Here, this one is this one. You're seeing this one. This one is the cavity insert. This is the cavity insert. Cavity insert is like this. When you observe the isometric view, this is the isometric view, and you are observing this is the front view of the cavity insert. And here also doesn't, it comes to your view as the top view is of the only of the bottom half. While you designing the cavity insert, you have to come to get the note to that this is the section. This is the section is made. This is the section is made in the cavity insert for the easy movement of the for the movement of the side core. Here, this one. For your reference, I am given some of the basic dimensions of the core insert. Here, this is the total length and total width and the height of the component, and these are all the core insert in the machine. For the core insert, for the component has got the depressions inside, and here you are observing the depressions in the cavity insert, for you have to get the component. At the same time, the recess or the sectioning is done to some of the material. The dimension I had given here for this section, that one is the 40 and the length of this one is 30. So as the side core has to move, come and outside. Where the side core has got the profile, that is the boss for the component, and in this side core also have a pin is placed for the component has to get the hole. And one thing you are observing, this one in this side core, the pin is secured perfectly by the use of the grub screws. You are observing, this one is the pin, and back side is the grub screws. You are going to see this one is the side core, and this one is the pin, and this back side is the grub screws, and this one is the threading has been done, internal threading of M8, by which the from the back side the grub screws is fastened perfectly, so that during the operation of the molten metal into the core, by the force, the pin should not come outside from the side core. So the core pin is secured perfectly by grub screws. You have to while designing, you have to have the knowledge about the draft also. The pin should have a minimum side of the draft, and the boss or the profile in the side core, that also has got the draft, because the component has to be ejected easily. While sectioning, you are going to see that this one, and this is the bottom plate, and this one is the ejector assembly plate, and spacers, and then back plate is placed. That one is the core back plate, and again this one is core housing plate, and this is the core or the wear plate. This one is the cavity housing plate. Sorry, this is the core housing. I am showing here the core housing plate. This is the core housing plate, and this is the cavity housing plate. I didn't show them. And here it is the wedge, and this one is the guide. This is the guide. This guide is shown here, 1 and 2. This is the guide here, 1 and 2. Similarly, or here it is the wedge. You are saying this one is the wedge. The main purpose of the wedge, you know that it locks the side core during the process, and while opening the mold, it releases the side core from the cavity. After you come to know the hatching or the sectioning, section A, and here it is the A dash. You have to write it on section A dash, and this is the front view of the tool, and this is one is the top view. You have to write it like this, front view of the tool. If possible, you can go for the side view of the tool, where you can show the, if possible, while drawing in the drawing sheet, you can go for the side view. This one like this. You have to go for the side view of the tool, where sprue puller bush, and ejector pins with the core cavity can be shown. Similarly, here I want to show that this is the insert, and this is the main insert, HDS main insert. This insert here I am showing this one. Are you observing? This is the insert, This insert top view is this one. This insert core insert top view is this one. This insert isometric view is this one, and I had given the core insert dimensions also. This insert, this is the insert, and here this insert is placed in the core housing plate after assembling with the one insert here and one insert here. After assembling these insert into this, and this main insert, core insert, is placed in the core housing plate. Getting point? This insert, core insert is placed here, and this core insert is placed here, and after assembling the all core inserts, the core insert is placed in the core housing plate. Here you are observing the front view, and this is the insert. What you are seeing here is the insert, and this one is the component, and this one is the component. Here the component fills, the component fills as per the dimensions through the feed system, that is sprue, puller, then the runner, then gate, and then the cavity. It fills the cavity, and where the profile has been provided in the side core, the profile comes in on the cavity, and it is the side core. You are observing, this is the insert, this is the main cavity insert, and this one is the cavity insert, and the thing here you are observing is the side core. You are observing, this is the side core. The side core movement is actuated by the finger cam. You are observing this one. I had given the here side core isometric view. I had given for your reference. Side core isometric given for your reference. You are seeing this one. I had also given the dimensions. Here. Also given the dimensions also here. Here the width, the length, the height. The only thing I didn't here, I shown the isometric view of the side core. The side core, this is the side core, and this is the side core. This side core is in the front view. The same thing is I shown here the isometric view. I given the reference dimensions, and this section view also shown here, and this is the depression by which the component gets the boss, and this is the pin, the core pin, which is used to get the hole in the component, and the arrangement backside is made. The core pin backside fastened by the grub screw. This is the grub screw, and here internal threading is made of M8. And one more thing is, you are observing the core housing plate. This is the core housing plate arrangement before the assembly of the core insert. This core insert in this one, and this one is this one, and this is the cavity insert. This is the cavity insert, and you are observing the profile, the outer profile of the component, where you have to draw during the core and cavity details, and you have to draw this one, and this one for the core and cavity details. This is the thing I had given the light over the plastic injection mold with the side core. The main specialty of this tool is this component requires only one side, the side core. Here you are observing the total tool, top view, front view, and then the inserts, and then the plate, and then the main insert, and then the side cavity. This is the introduction to this tool. If you have any doubt, you can call me for the future clearances about this tool. Thank you. What body?